remember how in one of the first lectures in the course, we decided that we're going to think about functions like x of t as not just providing a way to go from a numerical input to a numerical output, but as a way of describing the state of a system at a given time. So we think of t as representing time and x as representing the state of a system. So there's one kind of system whose state can be represented by one number and which is visually very useful. And that's a particle in one dimension. So if you have a line and a particle, like this thing here, can move around along that line, then as long as you pick some units of measurement and some origin to measure from, like some place to call 0, then the location of the particle is can be given by a number. And what the dynamics of the particle, what the particle does in time, can be given by a function x of t. So this sounds like it's just one example, a particle moving in one dimension. But it's actually the example that we use to visualize basically all other examples. So we use this particle in one dimension kind of way of thinking as a way of thinking about all kinds of systems where the state is represented by one number. So, for example, if it's actually the temperature of an object, and the object is in an environment, maybe you're doing Newton's law of cooling or something like that, but the system that you're following is like maybe the temperature of my coffee here in the room, then that's one number, the temperature, and it can change in time. And instead of having like an x-axis, I might call it a capital T axis. And I might think of the current state of the temperature as just a point somewhere on the t-axis, and that point can move around in time. So as my coffee cools down, this point sort of moves to the left to smaller and smaller numbers. So when we do this, when we draw this like one, when we draw a line and put a dot on the line to represent the state of a system, and think of the sort of coordinate along the line as representing the state of the system, the line is called a phase line. So these are examples of phase lines. And it's actually just like a picture that you've seen before, but with less information in it. So one way you might think about visualizing solutions, for example, say you've got the equation x prime equals rx for like population growth or something, and you solve it, and maybe you have an initial condition like x of 0 equals 3, and then you solve it and you get x of t equals 3e to the rt. Then you plot that and you get something in this picture here. The population starts at 3 and it increases exponentially from there. So this hopefully is a kind of familiar picture. What I'd like to point out is that what I'm referring to in this previous board here as the phase line, the x or the t-axis, is the vertical axis here with the time information kind of removed. So if you just focus on this, that's the phase line. It's the x-axis. In this example, maybe it was some population. So just take this vertical axis, flip it around, and forget about the time axis. So this would be our x-axis, and then just be like, okay, the population starts at 3, and then what happens in time? As you increase time, the population grows. So at first so imagine this green dot just moving, an animation of the green dot moving. So as time goes on, it's sort of, if you take snapshots at equal time intervals maybe, then you would see the green dot sort of go faster and faster as it moves to the right. Actually, I can use Mathematica to show you an actual animation. Okay, so here I've set r to be 1, just to make a choice about r. and I'm going to plot 3e to the rt from t equals 0 to t equals 2, say, 2 units of time, and you see this exponential growth. And it's a little bit off-putting that the vertical axis 0 is not at the bottom. So let me just do this. There. So it starts at 3, and then it grows exponentially. So this is the kind of plot that you're used to seeing. Now let me show you how we would visualize this on a phase diagram. So yeah, this is also called a phase diagram when you make one of these diagrams, with a bunch of information that we're going to add into it in a moment. Okay, so how would you visualize this in the phase line way of thinking? So the first thing I'll do is draw a phase line. So if up here this was time on the horizontal axis and population on the vertical axis, then you're sort of observing the population grow in time along this curve. Here, the one horizontal line that I'm drawing is like the vertical axis here. It's just the population axis. So this is the population axis, and different dots on this line are going to represent different populations. The initial population is wherever the dot at 3 is. Okay, so here I've added a bunch of code to just show a green dot at the position 3. I've arranged it so that 0 is to the very left here, and here's a green dot at 3. That represents the population is 3, maybe 3 million people or whatever. I haven't specified the units, but this green dot at position 3 represents the population is 3. So this is like the initial condition. The population is this much. Then as you let time go on, the dot, if you expect the population to grow like this plot shows, then the dot should move to the right. Okay, so here I've modified things so that it shows an animation, and this is the sort of the x-coordinate, or the coordinate, how far from the left the dot is drawn. And it starts out at 3 when time is 0, and time is going to run from 0 to 2 throughout the animation. So if I play this, then you see the dot starts at 3 and the population grows exponentially. You see how it's accelerating as it goes to the right. Okay, so this is just another way of visualizing the same information that's contained in x of t when you plot it. This is just another way of visualizing it. And you might think, well, isn't the plot purely superior of a visualization compared to this? Well, yes and no. For certain purposes, this kind of visualization of phase line is going to be helpful because, for one thing, it declutters and helps us to focus on what's important for certain situations that you're about to see. And another reason we might prefer this is later on in the course, we're going to shift our focus to systems where the state can be described using more than one number. So where one number is not sufficient to describe the state of the system. And for those kinds of situations, the phase line will have to be replaced by a phase plane, where you have two axes sort of representing the different ways in which a system can change, a system state can change. And for those situations, there's not going to be a convenient way to plot like this, to do a time series plot for solutions. So simplifying things down right now while we're working with one-dimensional systems where there's just one unknown function, x of t, will help us to still be able to draw things and visualize things later on when we look at higher dimensional systems.